3 billion pounds of almonds, and California is ending its clearest independent crop count. What breaks first is not the factory, but the number behind it, a crop. This large turns the San Joaquin Valley into a race of trees, trucks, dryers, and factory belts. Each orchard carries a long water debt before a shaker ever touches the trunk. Soon, the market will lose a field-based estimate that helped buyers judge the crop before warehouses filled. In this video, we explore why that missing count changes how California almonds are priced, trusted, and moved. Almonds look like a fast crop only after they leave the orchard. In 2025, California reported 3.0 billion pounds of almonds, the second largest harvest on record from a state that supplies about 80% of the world market. That volume is concentrated in the Central Valley, especially San Joaquin Valley counties built around flat land, irrigation, packing plants, and export logistics. The orchard footprint has been described as the size of Delaware, plus another 10%. But scale here does not start with harvest machines. It starts with nursery trees, irrigation lines, berms, pruning, weed control, and several years of cost before the first serious crop. An almond orchard takes about 3 to 4 years to produce commercially. Then it can keep producing for 25 to 30 years, with peak output between years 7 and 20. That long life is the hidden wager in every planting. Once the trees are in, a grower cannot quickly shift away when water costs rise, prices weaken, or pollination becomes more expensive. The central mismatch is between factory speed and tree time. The trade wants quick numbers, quick movement, and clean contracts, but the orchard answers in seasons and decades. Pollination tightens the calendar before harvest begins. Almonds depend on a narrow seasonal window, and bee colony losses can turn that window into a costly bottleneck. Then the crop is pushed through machines. Shakers, sweepers, collection rigs, hullers, shellers, sorters, storage bins, trucks, and buyers all meet the same hard clock. £3 billion is not just a harvest size. It is pressure on roads, warehouses, workers, processors, and every price written before the crop is fully understood. Now one of the market's measuring tools is being removed. After the July 2026 report, the Almond Board of California will end funding for the USDA Objective Measurement Program. Forecasts will continue, but with less field-based measurement behind them. That matters when the 2026 forecast is already pulling back from the huge 2025 crop. The result is a more fragile almond empire. California can move a crop at industrial speed, but it must still price that crop against scarce water, costly pollination, and a fading field count. Behind the orchards, strength and risk are planted together. Every new tree ties land, water, labor, and debt to a bet measured in decades. A crop this small in the hand can demand more water than seems possible. By direct irrigation estimates, a single almond can take more than a gallon of water before it reaches a sheller or a roaster. That number carries the whole argument. In a crop built for global scale, water is not a background input. It is the hidden bulk behind every shipment. Almonds are not a crop that can be parked for a season. They are permanent trees, capital tied into trunks, roots, pumps, filters, and contracts. A grower can cut back a row crop when water runs short. An almond orchard has to be kept alive and productive, even when local allocations tighten. The hard part is timing. California gets most of its rain in winter, while almond trees keep asking for moisture through spring growth, kernel fill, summer heat, and hull split. That mismatch turns water into a production schedule. Reservoir releases, canal deliveries, and groundwater pumping all have to meet the biology of a tree that cannot wait for a better month. Under that pressure, the path from pump to root has become heavily engineered. Drip lines and micro sprinklers are the hardware of farming under constraint. Sensors read soil moisture in real time. Evapotranspiration data estimates what heat and wind pull from the trees, and pressure chambers show when the tree itself is under stress. The goal is not to make almonds dryland farming. The goal is to stop water from leaving as runoff, deep percolation, or uneven watering. Precision changes the margin. It sends water into the root zone, not across bare ground, and it lets crews correct a weak block before yield slips. But the basic constraint does not move. Every living almond acre must push large volumes of water through leaves to build a kernel the market will accept. Stress this year does not stay in this year. Small kernels can cut returns at harvest, and weak bud formation can carry the penalty into the next crop. That is why water pressure is also market pressure. A tight allocation is not just a farm problem. It can reshape crop size, factory throughput, truck schedules, and buyer commitments. The technology has made almond farming sharper, not lighter. It reduces waste, measures stress, and buys time against a narrower water window. The hard limit remains. Trees need water, and scale makes it impossible to hide. A 3 billion pound almond crop can spend 7 years coming into bearing, then hinge on a few weeks of bee work. The global market may see a record-scale crop, but the annual yield still depends on bloom timing in one state. A young orchard takes years and water before it carries a mature crop, but the annual yield is decided much faster, when flowers open and pollen has to move. Almonds bloom before many other major crops, so commercial beekeepers are pulled from many regions into California for a concentrated February job. Hives cannot arrive as an afterthought. 2 weeks early or late can turn a full bloom into a weaker nut set. Now the bloom itself is moving. UC Cooperative Extension data show blossoms in many orchards appearing in early February, and in some regions 3 to 4 weeks ahead of historical averages. That shift compresses a chain already running tight. Transport, orchard access, weather windows, and bee strength after winter. Every delay lands inside the same short bloom. At bloom, factory power has almost no leverage. A machine can handle a crop later, but it cannot create a nut that was never set. Then came a number growers could not treat as background. The 2024 to 2025 season posted a nearly 56% annual colony loss rate, the highest since surveys began in 2007. For commercial beekeepers supplying almond orchards, the pressure was heavier. Nearly 62% of hives were lost. The previous season had already set a record at just over 55%. A grower facing bloom cannot wait for the market to calm down. For 2025, hive rentals were reported anecdotally at about $220 to $250 per colony. That price is not just a cost line. It signals that pollination has become scarce, pressed by weather, trucking, winter bee strength, and the size of almond demand. Self-fertile varieties such as Independence are growing, and they matter, but they still hold a small share of bearing acreage, so most orchards remain tied to the hive schedule. Even the easing after that crisis did not remove the weak point. The 2025 to 2026 bee loss rate fell to about 40%, still high enough to keep pollination near the front of the ledger. Before California can shake, hull, shell, store, and price the harvest, it must first clear a February biological test that no factory can rebuild. The harvest begins with a crack, not a machine. After 6 to 8 months, each tree has turned February bloom, water, leaves, and heat into a kernel locked inside shell and hull. And almond is a droop, green hull outside, hard shell beneath, edible kernel forming in the center. Through spring and early summer, shoots, leaves, and nut load draw from the same water and nutrients. By late summer, the hull dries along its seam. The first split is small, but the order is large. It says the crop is close. It also starts the countdown that decides how much value leaves the field. Once the hull opens, protection changes. Air, dust, insects, weather, and mold pressure can reach a nut sealed for months. Navel orange worm pressure rises after split, especially where old nuts remain in the orchard. A clean floor is protection, not polish. Waiting too long can leave kernels darker, stained, or marked by insects. It can raise rejects at the processor. Moving too early brings another penalty. Green hulls can cling to the shell, and drying turns uneven. So growers do not chase a calendar date alone. They read percent hull split, nut moisture, pest pressure, floor condition, and the forecast. A biological signal becomes an industrial order. When enough hulls split, machinery, labor, trucks, and handlers wait on one clock. At California scale, the timing is unforgiving. One delayed block can ripple into receiving yards and contracts. Because the valley sits at the center of global supply, one region's timing reaches contracts far beyond the orchard. Water pressure makes the moment harsher. By hull split, months of scarce water and fieldwork are already invested. Delay can turn that investment into lower-grade crop, while a rushed pass can send sticky hulls and uneven moisture into the chain. Factory speed begins before the factory. The processor can only sort, size, and reject what the orchard sends in. Timing in the block becomes upstream quality control, and the smallest crack starts moving money, labor, and capacity. The crack also exposes a wider weakness. The market wants certainty before the field has finished making quality. Hull split turns the Almond Valley into a race, where lateness shows up as quality loss before it ever shows up in a price. And almond tree is no longer cleared by hand crews. It is gripped, shaken, and emptied on a clock. In less than 30 seconds, a trunk shaker can drop thousands of almonds, replacing a crew of about 10 workers. Before that clamp closes, the orchard floor has already been turned into a work surface. Grass is mowed, ground is leveled, and debris is cleared so the crop can dry and be recovered cleanly. The shaker has padded jaws, but hydraulic force does the work. The operator needs enough vibration to clear the canopy without scarring bark, stressing roots, or cracking scaffold limbs. The margin is narrow. One setting moves a crop into the supply chain. A rough setting leaves trouble for next season. This is where labor changes shape. Fewer hands work the canopy, but more skill moves into seats, repair trucks, fuel tanks, and radio schedules. Across roughly 1.4 million acres, that shift becomes valley pressure. Shakers, sweepers, pickups, carts, and trucks have to move before weather or factory demand catches them. At California scale, a finished crop cannot wait in an orchard. After shaking, the field becomes the first drying yard. Rotating brushes and air push almonds into windrows, tight enough for pickup machines and open enough for heat. Traditional field drying carries much of the work. Several days in the California sun, often 1 to 2 weeks, pull moisture down and make hulls brittle. That dry spell is useful, but it is also exposure. Dust, soil contact, wind, and autumn rain can turn neat rows into risk before a factory sees them. This is why off-ground collection and mechanized drying are gaining ground. They cut soil contact and shrink the weather window around a finished crop. Then the pickup machines take over. They lift windrows, shake out sticks and clods, and feed trailers bound for hulling and shelling plants. Water pressure sits behind every pass of steel. By harvest, scarce water has already been converted into a crop. The remaining question is speed. The pricing question adds another layer. The faster the crop leaves the field, the more the market wants proof of how much is really moving. The orchard has become an outdoor production line. Minutes matter, but dust, weather, water limits, and market doubt still get a vote. The almond crop leaves the orchard looking less like food than freight. California is moving a near-record almond crop, yet the first loads are bulkier than any kernel count suggests. Field work may start under the trees, but the San Joaquin Valley harvest is decided at scales and receiving pits. Pickup machines feed trailers. Trailers feed yards, hullers, and shellers. The first surprise is the roughness of the material. Hulls, shells, sticks, dust, and moisture ride with the crop before a clean kernel reaches storage. That extra bulk matters because every pound has to be hauled, weighed, sampled, and routed. A clean final count hides the heavier first movement behind it. At peak harvest, some processing plants can take hundreds of truck deliveries in a single day. That is not scenery, it is a receiving window under pressure. Growers, custom crews, truck dispatchers, scale operators, and plant managers all work inside the same narrow clock. One late pickup can crowd a yard. One backed up scale can slow an orchard. The loads do not arrive as identical cargo. Each one is checked for weight, moisture, and foreign material, because quality and payment begin before the almonds are processed. Staging buys time, but not much. Loads may be tarped or held in yards, while wet nuts keep pushing the schedule toward risk. Autumn rain is the hard cutoff. It can re-wet windrows, soften orchard floors, slow pickups, and stack more trucks outside crowded plants. Here, a huge crop becomes fragile. Water stress may shape the orchard, but weather and processing speed shape the harvest after shaking is done. The valley's rural roads carry more than almonds. They carry contracts, cash flow, labor hours, and the first proof of what the crop actually weighs. That proof matters more as trusted field measurement fades from the pricing picture. When less is known before harvest, every truckload becomes a harder piece of evidence. The truck network is not an afterthought here. It turns field volume into market volume. After hulling and shelling, the crop moves again. Warehouses, pasteurization lines, cold storage, buyers, export containers, ports. The harvest keeps changing hands, but the clock stays on it. In the San Joaquin Valley, the orchard is only the starting line. The crop becomes real when trucks move it faster than weather, moisture, and uncertainty can close in. The quietest decision in almonds may happen after harvest, when a kernel meets a camera and a blast of air. California is pushing a near-record 2025 crop toward plants that can run around the clock and handle millions of pounds a day. At the plant, dusty field bulk becomes controlled industrial flow. This is where weight starts turning into global value. Every truckload has to be weighed and sampled before the machinery can claim it. A crop this large cannot move on guesswork. It needs records, lots, grades, and custody. The first task is against field material. Air, screens, magnets, and gravity pull out leaves, sticks, stones, dirt, and foreign objects. Only then can the almond move closer to food. The line has to strip away the orchard before it can sell the kernel. A hull stripper removes the dried outer hull, and cracking equipment splits the hard shell at thousands of impacts per minute to free the kernel without turning value into fragments. Hulls and shells are not simple waste. Hulls can move into livestock feed, while shells may go to bedding, biomass, or lower value outlets. When billions of pounds move, even rough outer layers carry a price signal. The kernel is the premium center, but it is not safe from rejection. Sorters separate size, chips, splits, discoloration, insect damage, mold, and foreign material. Food safety adds another hard checkpoint. Before shipping, California almonds pass through a mandatory validated treatment program using steam, heat, or other approved methods to reduce pathogen risk. Industrial pace cannot outrun public health rules. The faster the crop moves, the more discipline the line needs. Then, the cameras take over part of the judgment. AI optical sorters use high-speed cameras on each kernel and compressed air jets to eject defective almonds from the flow. More than 2,000 almonds can be inspected and sorted in the time it takes to hear one sentence. Quality becomes a split-second mechanical call. By then, the nut is pure trade. Steam, screens, steel, and software decide whether almonds ship natural, sliced, diced, roasted, or in bulk. But the plant can only measure what arrives. It cannot put water back into the orchard or repair weak pollination. Beyond the plant, the market will soon lean harder on records like these, as field-based crop counts thin out. By then, price is not just a number. It is the record of scarce water, industrial speed, and machine judgment on each kernel. The next almond shock is not in the orchard, it is in the counting. After a 2025 harvest of 3.0 billion pounds, the second largest on record, California's almond trade is moving toward its final USDA objective estimate in July 2026. For years, that estimate gave the market something harder than rumor. It came from field sampling, not only from opinions, voluntary replies, or warehouse talk. The program tried to count what was physically on the trees: nut set, size, sample weight, bearing acreage, and expected kernel output before harvest was finished. That count carried force. It shaped grower expectations, handler contracts, factory schedules, export commitments, warehouse space, and prices before the crop was fully in. In a crop this large, a forecast is not paperwork. It becomes a load plan for processors, a risk marker for lenders, and a pressure point for buyers. California grows roughly 80% of the world's almonds, so its early crop number travels far beyond the San Joaquin Valley. A small change on paper can tighten or loosen markets across oceans. But precision came with friction. The program drew years of debate over how the count was built, and wide uncertainty ranges could swing commodity prices while doubt remained high. That is the hard bind of agricultural data. A number can steady a market, but it can also push the market before the crop is truly known. The 2025 harvest proved California can move the scale. The end of objective measurement tests something harder, whether a global market can price scarcity and speed when its strongest field proof is gone. The plain takeaway is this: almond factories can move the crop with hard efficiency, but the market still needs a measure it can trust. When that measure weakens, risk moves from the orchard into every contract. The series continues with food supply chains where scale, scarcity, and measurement decide the real price.